when you take the derivative or the integral, there are some factors that show up. So, for example,
you could be dumb and not know what a derivative is, and that fucks everything up.
You want to learn multivariable? We can do that.
I'm going to stay away from the integrals because I think that's where we broke Eris. And stick with
You
derivatives.
broke me as soon as that there was an A that equals an M and there was an M and
well,
A.
So I am going to actually start by teaching derivatives, regular derivatives, in a slightly different light. But in this context, what we're dealing with is, the starting point. While yes, Astra started with velocity, the initial physical idea that we were thinking about is position as a function of time, right? Where are you? How far along this path are you at a given time? And then we asked, well, if we ask about the slope of that function, so how much position changes in a certain amount of time, well, that gives us velocity. And then if we ask how much does velocity change in a given amount of time, that gives us acceleration.
Okay.
And the whole derivative thing is just, derivative is the function, so the equation, that quantifies the slope.
So why do they not just say slope?
Because we like our fancy terms.
Oh my god!
Derivative just means slope.
What the fuck? You don't need a new word!
But she got it!
She got it! M equals A, man!
And I did that all with words.
And you don't need them! You did no!
I think the only reason we use derivative is because we're being
Pretentious? Yeah,
pretentious.
I agree.
So
So
here.
the derivative is what the slope was and what the slope shall be.
So for here, we
But
know...
what if the slope is consistent and we already know that because it's
That's-
a fucking slope?
Then it's a boring derivative.
Well, see how in this
I
one,
like boring.
Eris, you see how in this position, the slope is constant. So the derivative is just a number.
Yeah.
But for this graph, the slope is changing.
It's a parabola, so it's
Yeah,
like
the
what,
slope
x squared?
changes.
Something like that?
Yeah.
I mean, yes, in this case, yes.
Yes.
Hey!
And if it's
This-
x squared, that means that the derivative is 2x.
The derivative, so if the velocity goes as time, so velocity in this case, meters per second, is just equal to the time in seconds. When you take the derivative,
I'm trying.
maybe, so when I say the derivative, the notation that's commonly used has d's in it. It doesn't matter.
Multiple d's in it?
Multiple.
Ugh.
If it's a full derivative, 2 d's. Always at least 2 d's. And I'm going to do this in freedom units because that's how we've been talking about it.
What is freedom
Imperial
units!
units.
Miles, inches,
Thanks, United
ounces,
States.
pounds. Freedom units.
Can we not?
Y. Actually, you know what? I'm going to use a different variable because it's going to make it a little easier going on. I'm going to introduce Z.
Hi, Z. I'm Eris.
Z is the variable. Z is pleased to meet you. So Z represents our elevation.
Mm-hmm.
How high we are.
Okay.
No, it's hi. How are you?
X now is our position along the trail horizontally.
We make good decisions here.
Listen, I've started making better decisions, but this is not one of them.
It was about 6 miles to hike in.
Yeah.
Right? And I'm going to say we started at 4,000 feet. I'm not sure if that's right, but we're just going to estimate it as 4,000. So this is our function.
Mm-hmm.
So we started at about 4,000 feet, maybe a little less. And we climbed for the first probably about 2 miles pretty steadily. Up.
There were a lot of switchbacks.
Yep. But we went up, right? And we gained about 1,000 feet. And then it became a little bit more flat. There was some bits of up.
We'll draw the cinder cone. That cinder cone.
We haven't gotten to the cinder cone yet. At about 3 miles, there was that big uphill that we did, kind of in the sand right before we hit the official end of trail. Right? That got us to about to mile 3.
Oh, to the tourist ridge.
Yeah. So we made it to the tourist ridge right about mile 3. All cool. Then we continued flat for a little bit.
Trail not maintained.
Yep.
Same.
At around mile 4, we hit that cinder cone, gained some more elevation, had a little bit of flat up, even some down in places, and we kind of meandered our way all the way up.
Does that include the time where we climbed up a bunch of rocks?
Yes.
Yes.
But not the time where we climbed down all those lava rocks.
Climbing some rocks all the way up.
That was fun before my thighs and my butt hurt.
To our destination, around 6 miles, maybe a little past.
Yes,
your rock that you
rock.
sunned yourself on.
My lizard heated rock.
Now that derivative thing that Astra was talking about. She was talking about how we quantify the slope, right? We could quantify the slope too. Now this is not in terms of the distance as a function of time. This is elevation as a function of horizontal distance traveled.
So it's the y and the x-axis. But
Yeah.
like,
We're gonna call it z, and you'll see why I'm calling it z for the vertical.
mhm.
Okay.
Is that
in a
its
little bit.
preferred name?
Yes, his
Yes.
preferred pronouns is
Yes.
Z.
Got it.
Vertical direction prefers z.
Got it.
If we wanted to quantify the slope between the end of the first mile and the start of the second mile, how would we calculate it?
With a hope and a prayer.
That is true. But let's be more specific.
Alright, I'm gonna hope that I understand this and pray that I guess the number right.
And you might have heard this in some of your math classes, the rise over the run.
Yeah.
Basically, how much we've gone up for how far we've traveled.
The steepness.
Well, if it's a close approximation in terms of the slope of this, I would call it closer to like a 1.5 overall.
1.5 what?
With Z units.
Well, you see how that one was 1, but that one's not as steep at the end. So just well, here, if we wanted to get the average, let's get the average slope
Anything
overall.
can be 1 if you use the right units. The speed of light is 1 if you use the right units.
Don't make
Let's
fun of me.
use-
It's
let's-
my special day.
Let's not do this section yet. Let's do the whole thing.
Yeah, that's what I was talking
Yep.
about.
Exactly. So let's do that.
Why are you making this so hard for Eris? You're giving her trauma.
Oh my god, this
And
is
I've
like,
been so nice. I'm not even roasting you or anything.
This is like how I was trying to talk to my partner. And like, it's a lower slope than what we anticipated when we were bad at the climate change thing. And he's like, what do you mean? It plateaus. It stops. And I'm like, no, but before then, the slope, it changes. He's like, what are you talking about? It plateaus. Between this point and this point before the plateau, there is a slope that is less steep than when we initially calculated this, when things were worse. And he was like, oh, yes. Yes,
And
you're
guess what?
correct.
You were doing calculus. Congratulations.
Yeah, you did a calculus.
I had definitely had a breakdown, and my partner will be watching this video for sure, and I'll go, see, I was doing calculus, you motherfucker!
Let's do a little bit more calculus. And let's say, what is the slope on average? So, you want to tell someone on average how steep is the Tam MacArthur Room Trail all the way up to No Name Lake. So the way we calculate that is this rise over run thing that you might have heard about. Basically, we want to know how many feet of elevation did we gain per mile that we traveled. Right?
Yep.
So, how much elevation did we gain total? This is our rise.
A lot.
But if you look at look at this graph.
It's 6,000 minus 4,000.
Oh, that's 2,000.
Good job.
Yep. So this thing right here is our rise, or equivalently, it's the change in z that we had.
So this would be 2,000 divided by the distance for the run. So that's 2,000 divided by 6.
What's 6 minus 0?
6 minus 0 is 6.
And we're gonna, so this is the change in z, right?
Mm-hmm.
This is the change, and I'm using the symbol delta here.
Yeah, I recognize that. There's an airline.
Yep. So the symbol delta is commonly used. It is an airline too.
Yeah.
But the symbol delta, the Greek letter delta, is commonly used to represent the change in.
I did learn the Greek alphabet in 2nd grade, so.
So that's why I'm using delta here. So delta x, we said, is 6,000 miles. So if I wanted the slope, also known as delta z over delta x.
You gotta show the
Where's
graph.
Got it? Good.
We'll take pictures. I can.
Is equal to 2,000 feet over
6,000.
6,000. I'm keeping the units here to make it clear that these are actually different units.
Oh, so it's not 6,000 divided by 2,000. It's 2,000 divided by 6,000.
Correct.
So that's 1/3.
Yep. So that means that you went 1/3 of a foot. Sorry, that should be 6,000 miles. That should be 6 miles.
Yeah.
I'm sorry.
I'm very confused as to where you got the extra
That's more.
the extra 5,994 miles.
Listen,
we
did
casually
not walk
hiked
that
the
far.
PCT like 3 times.
Casually.
Listen, I'm not saying that I'm really impressive. When
Okay,
it comes
this
to
is the
hiking.
correct
I've
one.
blown out
I had some wine and I accidentally added some zeros.
Sometimes
It's fine.
when you
Can we
have a
use
little
your mouth?
wine, you accidentally hike the PCT a couple
So
times.
now it's 2,000 feet per 6 miles.
So is it 300?
1/3 of a foot per mile.
No.
No. 300 feet per... No.
No, it's 300, right?
Yeah. Right?
No, 3,000?
No.
No, 3.
No, that's more.
No, it's 3. There's a 3 somewhere.
It's
So what's 2,000
it's
divided by 6? We can do
1/3.
that on a calculator. if you want.
300, right?
no. It's
Fuck.
No.
It's 1,000 feet per 3 miles, which I think is what you were thinking.
Yep. So it's the same as 1,000 over 3.
Oh,
I think
So
we
it's
might
about
be
333.
333.
Correct?
0.3333.
Yes. So the idea is
Oh.
we gained about 300 feet, 333 feet
Mm-hmm.
for every mile that we hiked.
Yeah.
Flat. Cool. What if someone, instead of asking you about the average slope on this hike, was like, how steep does it get? Right?
Less steep than Toblerone.
Tumalo. Toblerones are pretty steep. Like, that's a pretty sharp triangle.
Yeah,
right
that
there.
is much steeper than.
I don't think we could climb a Toblerone.
Yeah.
They are a very large Toblerone.
You could climb it if you take tiny steps.
People have, but they're modeled after a very steep mountain.
Okay. I feel like I'm getting it. I feel like
Yeah.
I'm getting it.
So we want to know, how steep does it get? Because this is what it is on average. But there's
Yeah.
a lot of flat crap in here, right?
Yeah.
What's the worst case scenario? The worst is probably somewhere toward the beginning.
Yeah.
Right?
I don't know, I thought that cinder cone was a lot.
Yeah,
Maybe.
climbing up those rocks almost made me twist my ankle.
Yeah. Okay, so maybe it was the rock. So it was somewhere out here. You had an instantaneous slope. So for that little bit, that was much steeper.
So that's more of like a step on a stair rather than like a walk up a slope.
Yeah, it was
It's
steep,
taking
right?
the stairs as opposed to the wheelchair accessible entrance.
Exactly. We had some moments there, right? You would
Yeah.
agree with that. And so in
My
those
thighs
moments,
felt it.
say we wanted to, instead of quantifying the average slope, we wanted to quantify the instantaneous slope. And let's say we wanted to do it here. So we would do the same exercise as this rise over run, but we want it just in this one point right there.
Tiny triangle.
Teeny tiny rise over a teeny tiny run.
Teeny tiny triangles.
And in fact,
I know
The
how to
thing
do
that
calculus,
makes
but I
it
didn't
true
even know it.
calculus is you can make it infinitesimally small rise over an infinitesimally small run.
Isn't that just fucking zero?
That,
then?
not quite, because there's a non-zero rise and a non-zero run.
Just like
Just
there's a non-zero
teeny
chance that
tiny.
you could get killed by bears at any moment.
Exactly.
Yeah.
It's just teeny
You know
tiny.
how black holes are infinitesimally small, but they could like also eat stars and your face?
Yeah.
That's this. It's teeny tiny. but
And the
important.
notation that we use in calculus for a teeny tiny rise and a
Code
teeny
words.
tiny run, instead of using deltas, we flip back to English and we use the letter.
It doesn't get degrees.
D.
Yes! So this thing right here is going to be,
D for derivative?
yep, dz over dx.
I know how derivative is spelled.
And
That's a lie, I
specifically,
don't.
this happened to, if we want to know what this one,
R-I-V.
this was at about the 5th mile. So dz dx
T-I-V.
is going to be the slope at any given moment.
I too
Along this
get
hike?
dizzy as well.
Yep. Dizzy is going to happen at any moment along the hike.
Yep, I understand.
But this one particular that I pointed out would be dz over dx at, and this is the notation with the parentheses, x equals 5.
dx.
And so the way that you would basically do it is, yeah, you look at what the slope is. So this is a full derivative. So the reason it's a full derivative is basically there are only two axes that we care about that matter for this function, the z-axis and the x-axis. The point of multivariable calculus is basically acknowledging that sometimes you don't just have two axes.
Because you don't always stay on trail.
Mountains are not
We're in the
two-dimensional.
3D.
They are three-dimensional. Are you ready to learn multivariable calculus?
Okay.
Or at least understand what a partial derivative means?
Listen, I'm gonna make the good old-fashioned try.
So we had the x direction, which we'll say was basically the horizontal direction of the trail.
Mm-hmm.
But let's draw the full Tam MacArthur rim. But really what it looks like is the trail direction does one thing. If you were to go perpendicular to the trail, so you're on the trail and you take a 90-degree turn, you kind of end up off a cliff in most cases, right? So the whole thing in
Certain
three
death.
dimensions.
Don't jump off cliffs. That Astra does not endorse jumping off cliffs.
So the A's are the same things as M's, and then there's the fancy F that the Elizabethans used, and then there's words, and then there's the Delta Airlines. Oh God, there are no numbers. Shh. I thought math had numbers.
So now we have
You gotta show.
There's a caterpillar now.
this thing. Yeah. I'm gonna explain it though. So this is the trail that we hiked.
Mm-hmm.
These are kind of the cliffs dropping off to the side. That's the lake where we started, right? We kind of went
That's
up and
right.
around like that. This is very approximate. Up here we have Mount Bachelor, way back behind, further that way.
Mm-hmm.
And over here is Broken Top, where we've kind of finished. Right? You get the picture. It's very rough, but you get the picture. Cool. But it's three-dimensional now. If we consider the three-dimensional thing, and we want the slope of the trail itself.
Sorry, I was asking if caterpillars pee. I don't know.
Do caterpillars pee, Nova?
Probably. And so now let's talk about derivatives. So, if we are here, and we were to continue walking along the trail, which we're saying is the x direction.
Yeah.
Right?
Yeah.
And we want to describe the slope of that.
It would be the Z.
Yeah, it would be dz dx.
Yeah.
Right?
It's.
However, if we're sitting here, and let's say we go directly in the y direction. So this is the y direction.
So we go down
right?
into the gully.
Right. So, if we go in this direction, the slope that describes that, it's technically not dz dx, because it's not a full derivative anymore. We have another dimension to worry about.
Is it
It's a-
dz, dx, dy?
We just use a different notation. That's all.
But
The
the
entire
same.
difference. It's instead of dz dx, we use sometimes it's called dir, sometimes it's just called partial. It's basically a curly d. So we'll say that if you go along the trail, the way you describe that slope is partial z, partial x. Where the only thing that I changed here is that it's now curly looking d.
That just looks
But
like different handwriting.
Yeah,
It's like
yes,
a
that's
font.
all it
It's
is.
a font change. Why
Yes,
did you put
correct.
it in italics?
The font change is to tell me that x right now is not the only dimension I have to worry about.
Okay.
Because yeah, it's not that steep if you stay on trail. But the fact that it's partial means that there are other ways you can go that could be less steep, that could be steeper.
See, so you're
In
paying
fact,
attention?
if you were to walk in the other dimension, so not in the x direction anymore, but
In the fourth dimension?
90 degrees, the third dimension,
Third
right?
dimension, okay.
Right?
Oh, no.
Dimension
See,
1,
see.
dimension 2, dimension
Neutrino,
3.
neutrino.
So if you were to start walking off 90 degrees relative to the trail,
I'd die.
yeah, you would encounter a slope, which I would describe as partial z. So still a certain amount of rise, but the run is much, much smaller, right? It would be a pretty big change in z for a very small change in y, which is never a good thing when you're hiking.
Mm.
That's a plummet to your death. Or a very, very steep mountain.
So that's partial z, partial y.
So how do
And
you
you
figure
could
out what
definitely
the
say-
partials are all together?
Well, that's the thing. You can't, there's no such thing as the full derivative in this sense because the function that you're describing, z,
There are
right,
two parts to the whole, though.
is a function of x and y, not just x.
Is there then a dz, or is there a dx, dy then? Or is that just slope?
So you could describe, so if you rearrange this function, in some cases you could describe how x changes as a function of y, but you don't really need it to describe this whole system.
Mm-hmm.
If you know how my mountain is going to change in this direction, and I know how the mountain is going to change 90 degrees to that direction, I have a good sense of how the whole mountain looks. I have the full topographic map.
Including all the difficult rocks?
Yep.
Yes.
Everything is described if you have two dimensions that are perpendicular to each other.
So if you know the east-west and you know the north-south,
You've got the whole mountain. If I know my elevation map, it's a function of all the east-west and all the north-south,
Even the tiny bits?
even the tiny bits. That's a full topographic map.
a very detailed topographical map.
So I have both partial derivatives. That gives me the full description of my slope in any given direction. The direction of steepest ascent, which would probably be pretty close to the y direction. We call that the gradient.
But gradients are a change in like
They can be a
colors.
change. Yeah, but in mathematical terms, it's not just a change in color.
Why does math need to steal for like names that already have definitions in English? Like, can't you come up with something more creative? Oh right,
Like-
you're scientists.
Like
yeah.
poof.
And Shazam. Eris?
Fuck you, Mr. Price.
If you were to ask what is the magnitude of partial z, partial x along the trail, well, that slope, at least the magnitude of it, is certainly smaller than the magnitude of partial z, partial y. Because partial z, partial y is extremely steep. In fact, it is deadly steep.
Stay on the trail, Eris.
Oh, yeah.
There was a lot of words to just stay on the trail. Don't jump off cliffs. Unless you have, like, parasails and chutes and stuff, and that's your
Or some
thing.
deep water below.
But you're all
That
adults.
is the beginning of multivariable calculus.
Oh, that's the beginning.
Shall we continue?
We're not going to continue down multivariable calculus.
No, it's my special day.
But the
Hey,
basic
I
idea
don't want to go.
is that there can be more than
I
two
want to
dimensions.
stop on the trail. I want to stop and turn around now.
The power of math is a curious thing. Make a one man weep, make another man sing. Check your hunch, numbers the right path. Prove what you're feeling, that's the power of math. Questions have answers you can find. Longer and larger when they're undefined. Gives you an answer, only one is right. Power of math will keep you home each night. You can track money, time and space. The universe's answers in one place. It's strong and it's sudden and it's cruel sometimes, but it makes stars shine at night. That's the power of math. That's the power of math.